Welcome to MRS Bulletin's Materials News Podcast, providing breakthrough news and interviews with researchers on hot topics in materials research. My name is Sophia Chen. Conventional electronics store information in the flow of electrons, described using currents and voltages. For example, high and low voltages across transistors on a computer chip correspond to either 0 or 1. But increasingly, electronic devices are making use of not just electrons, but photons too. Some types of hardware have begun to encode information directly into properties of light, such as in fluctuations in intensity or changes in frequency. Researchers are developing this class of devices, known as optoelectronics, for applications ranging from biomedical devices to computing. Now, researchers have come up with a concept for a new type of data storage using light. Victor Lopez Richard, a physicist at Federal University of San Carlos in Brazil, explains.
We're bringing memory functionalities to light-emitting devices or light sources.
Lopez Richard's team calls their concept a Mem-emitter. The Mem-emitter is made of a material that emits light when you drive it externally, such as with a voltage, or illuminate it with the right light. But the key is that the material has different states with different optical properties that you can toggle between.
It can tune the intensity of the light being emitted and also the energy of the wavelength of the photons being emitted.
So depending on the material's state, it might emit light that is brighter or dimmer, or it could emit light of two different colors. You could, for example, store binary information as one of those two states and read it out by illuminating it and detecting the emitted light. Using light for data storage has some advantages.
They can have some contactless readout, so you can see the readout from a distance. They can also be very fast because it is optical driven.
Notably, they propose making these Mem-emitters from materials known as transition metal dichalcogenides, layered on top of a semiconductor. These are atomic layer thin materials, also known as 2D materials.
They are very interesting systems because you can reduce them to very, very thin layers of atomic scale. So they will help, for instance, to reduce the size of devices.
They changed the optical properties of this material by applying a voltage across it. To study the changes, they applied triangular-shaped voltage signals and looked for changes in the electric polarization in the material.
All you have to do is to change certain internal variables. That could be, for instance, trapped charges in interfaces or defects, or you can make internal polarization fluctuate, and all these effects could tune the way the device emits light.
Lopez Richard's team was inspired to create Mem-emitters from an existing device known as a memristor, which is short for memory resistor. These are devices made of materials whose electrical resistance can be tuned. Much of the mathematics behind memristors is the same for Mem-emitters, but instead of tuning resistance, you're tuning optical properties. Experimentally, they have made a device out of molybdenum diselenide, which is a transition metal dichalcogenide, and layered it on a dielectric known as a clinochlore. They found that they were able to tune the intensity of the light emitted according to theoretical predictions. Now, they're studying how the Mem-emitters behave in other conditions, such as in varying magnetic fields, and they are looking into integrating them into photonics devices.
You could integrate the electrical abilities of the memristors with the optical abilities of these Mem-emitters and see how they could communicate. So this is something that is clearly very challenging, but we are hoping to get there at some point.
This work was published in a recent issue of Nano Letters. My name is Sophia Chen from the Materials Research Society. For more news, log on to the MRS Bulletin website at mrsbulletin.org and follow us on X @MRS Bulletin. Don't miss the next episode of MRS Bulletin Materials News. Subscribe now. Thanks for listening.